Welcome to the course I2204 Imperative Programming. I am Dr. Seba Haider. I will be teaching you this course. We will see about this course. We will see each other 3 times per week, Monday, Wednesday, and Friday, always in the same time slot from 9:50 to 11:30. On Monday, I will see you. I will prepare for you recorded offline videos. I will post them on YouTube and will put the link on Microsoft Teams. In this day, you will see a lesson, a recorded explanation of a lesson. Friday, we will do some exercises on this lesson online together on Microsoft Teams. There is an extension on Teams called Code. We will be using this extension in order to collaborate together to write programs. So I will pass the hand on for you one by one as much as I can in order to write the programs together. And on the next Wednesday, we will be applying a lab session. And for the lab session, we will do it on either HackerRank or Moodle. And we will be as instructors with you together on Microsoft Teams in order to help you with any questions, with any problems, and to give you feedback on your work. Okay, let's erase. As you know, this is a continuation for the course I1101, in which you were introduced to C language. This is a 50 hours course. That's why we see each other 3 times a week, and the resources will be available online after each lesson. I will make sure to post the slides and any other useful resource online, for example on Microsoft Teams, every time we explain a lesson. What are the course objectives? The purpose of this module, as you can now know, is to deepen the study of the imperative programming through the use of advanced aspects of the imperative language you have seen in I1101. So you have seen some useful aspects in this language, and we will deepen them. And the student must be able to implement the concepts covered in this course. After this course, you have to be able to implement all the concepts that you have learned in this course in order to create an application solving a complex problem as modules. So after this course, you will be able to solve complex problems as modules. As also, you may know that this course is also an introduction to the next semester's course, which is data structures. They are two related courses, and you are unable to understand data structures if you don't understand the advanced aspects that are presented in this course. So what we will see inside this course, we will be seeing the following topics. So we will begin by reviewing the recursive functions, by introducing what are the structures, and by revisiting the arrays and understanding the relationship with the pointers. And also in this course, we will be studying linked list in a very deep manner. And also we will study file input and outputs. So all these concepts are covered in this course. So let's not be late and let's begin our chapter 1, which is entitled Recursion. Begin chapter 1, which is entitled Recursion. So the chapter outline is the following. We will begin by recalling what are functions. We will remember together what are functions. We will write some of them. And then we will draw the memory state and we will understand what happens when we call a function. So when one function calls another one, what happens in reality? Then we will introduce recursive functions. I know that you were introduced to recursive functions at the end of the last year's course, but we will see them together again, and we will study their types and their rules and we will differentiate between direct and indirect recursion, and we will compare recursion and iteration, and we will see what are tail recursive function and non-tail recursive function, and we will study some problems of the recursion functions, and then we will study, of course, the effectiveness of recursion. So all these titles will be covered in this chapter, so let's begin. Recall of functions. So let's begin by remembering how to code. Let's do and solve this exercise 1. What is given in this exercise? Exercise 1. Write a C program which reads an integer number, comma, calculates its double, and displays it on the screen. What's an easy exercise? This is a very, very easy exercise. And then we have to draw the memory state. So let's begin by solving the C program. How to do this? So I have to write a C program which reads an integer number, calculates its double, 2 times this integer number, and then displays this on the screen. How do we do this? Let's go to the coding environment, and this is our hello world program. This is not the program we need to do. We will have to write a program that reads something from the keyboard, calculates its double, and print it. So in order to read something from the keyboard, the first thing I have to do is to declare a variable in which I have to read this number. So maybe I will declare int num, and then I have to read the value of num from the keyboard. Read the value of num. So what I have to do after introducing include stdio.h is to scanf this number from the keyboard. So scanf %d, comma, and num, and then I have to calculate its double. So let's declare another variable here. Let's call it num2, okay, and then I will say num2 is equal to 2 times num, and then I am asked to display this value on the screen. So I will use this line printf instead of hello world. I will have to display the value %d on the screen, which value? The value of the variable num2. So let us try this program. Run. Okay, allow. So here my program is waiting for me to introduce a number. Let me introduce the value 3, and he will print the value 6. So this is exactly what I was asked to do. So now this is not the purpose of this exercise. I know that you all know how to do this program. I know that you have supposedly passed the course I2204, and this is the easiest question that you might have seen in the exam. But what is the purpose of this exercise is to draw the memory state. So what is a memory state? The memory state is to be able to draw a draft of what we think has happened in the memory inside the computer. So what has happened inside the computer? I have prepared an Excel sheet for you in which I will draw the memory state. Because I cannot draw on the board, this will be very hard for me to draw using a mouse. So I have prepared on the Excel sheet a space that I have entitled memory state. Okay. Under these columns, I will draw every variable that is reserved on the memory. And this is very important concept. I need you to understand it very, very well, because we will be using the memory state method in order to understand all the course. Along with the memory state, I have prepared also two other spaces on this Excel sheet. One I called screen, so everything that will appear on the screen, I will write it here. So for example, in the first program, you will be seeing hello world like this. And everything we put in the keyboard, we will put here. For example, when I put 3 and then you saw 6 as a result. Okay, but between the user entering the value 3 and getting the double on the screen, what has really happened in the memory? So let us see what has really happened in the memory. How do we do? First, in the memory, I have only one function called main. It is the main function. So that's why inside the memory state, here now in this program, you will be seeing only one function. And this function has a dedicated space for it. In this space, we will declare and we will put all the variables that this function used. How many variables this function used? It has used two variables. One is called num and the other is called num2, and they are both of type int. So I will declare here two variables. One is called num and the other I will call it num2. And the variables, how do I represent them? I represent them as rectangular boxes in which I put the values. Okay, so this is only the tag. This is only the tag, the name of the variable, but the content of the variable, the value of the variable will be put inside the box. Okay, so let's see what happens. Next, after declaring the variables, look with me, both variables have the same size because they are both of type int. After declaring those variables, I will read the value of num from the keyboard. So suppose the user has put 3 inside the default input. This value 3 will come and will be the value of the variable num, because I said scanf, %d, and num. So what will be put in the keyboard will enter the value, enter the variable num. And then I said num2 equal to times num. So I will fill the value here by twice the value of num, which is 6. And then what happened? What really happened is that I printed the value of num2. So I take the value 6 from here and I will put it here. So this is the memory state as a first example. This must be very easy. You will have to understand it very easy, and I don't suppose you have to have any problems understanding this. Only what you have to know that after we encounter return 0, this is an int main, so this main must return 0 if, when success. So after the return of this function, so after we encounter the curly brace or the return, this function will not exist anymore. So the memory state, you saw me drawing main, drawing num inside main, num2, giving num values, etc. But after I encounter the curly braces, what happened? No main function exists anymore in the memory. This is what happened. You don't find anything in the memory, but you will see the value 6 and the value, you will see the value 6 on the screen. because this is the result of the execution. So when you see the value 6 here, this means the main returned and no more num and num2 variables inside the memory. This is the memory state. Let's do exercise 2 now. So let's do exercise 2 now. This is my pen. Exercise 2. Write a program which does the same as in exercise 1. Read a value, double it, and display it. This time using functions. So the program must call the function readNum in order to read the number and return it. A function double it only to calculate the double of the number, and a third function display only to display the result. Again, you will say this is very easy. It really doesn't need 3 functions to do it. We had only the main and it did well and it did the job. But we are taking easy examples in order to slowly introduce the concepts we are learning. So we want to learn what happens when these 3 functions collaborate, when readNum and double it and display collaborate to get a result. Okay, so write a program which does the same as in exercise 1, but this time using functions. The program calls, so the program, it means the main function will call in order these 3 functions and to get the result. And the most important thing again is after you have written these functions and the program and etc., you will have to draw the memory state. So let's go back to our program and let's modify it a little bit. Here in the main function, we don't have to write anything. We have to write readNum, double it, and display. So readNum is a function. Let's begin. readNum. It must take something and return something. So what must it take? It must take nothing, but what must it return? It must return an integer. The integer it has read. So readNum, we will declare int num. It has to read this number and to return it. Okay, scanf num and then return this number. That's why we said that readNum returns an integer. Then what will happen? We will write double it. Double it will take an integer, and what shall it return? Also an integer, the double of the integer it has read. Okay, let's call it num, and what happens here is that double num must declare, for example, num2. I know that we can do this without declaring num2. We can return 2 times num, but I am explicitly doing this so that I can draw the memory state for you and that you can understand. Num2 equal 2 times num, and then return num2. This is the second function, and the third function is to display the result. So the third function is of type void because it has not to do nothing, only display. It doesn't have to return anything. What shall display do? Display shall take a number, for example, take a number and display it on the screen. So I have already written also this part. I will take it from here. Paste, but here I have to watch out for the variable name. I called it number, so I will write number. So What does now main do? Main, it must declare a number, call the function readNum in order to read this number. Okay, call the function readNum in order to read this number. Then call the function double it in order to double this number. Let us declare also another variable num2, n2 equal double it, and then I have the value inside n2. I only have to display this, so I will call the function display to do it. Display n2 semicolon, and after all the successful job I will have to return 0. So again here I will compile. I have built failed, expected semicolon here. I will put the semicolon and then will compile and run. So again I will tell him allow, and the program is waiting for me to enter a value. Let's enter 15, and the program will return the value 30, which is the double of the value 15, and this is because the calls to the functions as a successive call succeeded. Okay, this is our exercise 2. We did the job that we were asked for. In this exercise, we made the main function call in order 3 other functions. And now I am asked to draw the memory state of this program. So I go to the memory state, and let me copy this memory state into the end. I will call it exercise 2. I will slowly draw the memory state. I don't want to prepare the memory state. I will slowly draw the memory state for you so that you know that what happens. Okay. So here this time I have more than one function. I want to insert more columns in order for each function to have 3 columns. 3. I will insert also more columns. Insert, insert, and insert. So the first, and I have also main. So I will insert also another 3 columns. So let's begin. This is for main. Merge and center. This will be the title of my function. Title. The other 3 columns are called merge and center. I will call them readNum. The other, okay, let's stay with main and readNum. Main is dedicated a memory for itself. Okay. How do I begin? Always we begin executing a program by the main function, even if here, as you can see, the main function is the last one written, but we will begin executing a program by executing the main function. In the main function, I have two variables that are declared, n and n2. So I will begin by reserving two places. One box I will call n, okay, this is n, and the other I will call n2. And they are both, just like the first exercise, they are both integers. Okay. And then I come to this line, the line number 19. What is written inside this line? N equal read num. Here I see that there is a call for the function read num. How do I know this is a function? I know this is a function because there are parentheses here. So I know this is a function called read num. So I search in the code, where is the function read num? Where is it defined? I find it here, int read num, empty brackets, and curly braces. When there is curly braces, this means this is a function definition. So I will leave main, but main will not be deleted. It will be remaining here because I didn't encounter, neither I encountered return. Return is in the line 22 and I'm now in the line 19. So I neither encountered a return statement nor a closing curly space. So the function main is still alive in the Excel sheet, okay, in the memory state, let's say. So, but I will leave main and go to the read num in order to execute read num. Inside read num, what do I find? Empty parentheses, just like main. There is no declaration of parameters. Okay, no problem. I go one line and there is int num. So inside read num, let me give it a space. I find that there has to be a variable called num. So let's choose this to be the variable called num. I will give it a shape so that you can see it. I will prepare here the name for this variable that I will write to be equal to num. Okay, after int num, I have to scan f this number from the keyboard. Again, let's see. Let's suppose inside the keyboard I have put the number 15. Okay, so I have put the number 15 inside the keyboard, so it will become here inside the function read num. Num will be equal to 15, not n here. Even if I have named this variable, which is n inside main, even if I have named it num, it will not be equal to 15. What I have filled with the value 15 is I have filled the variable num that is inside the function read num only, not the other variables called num in other functions. Every function has its own scope, its own space, its own variables. Okay, just imagine this like every house has his own children, and even if there is a children in another house that has the same name, this doesn't mean this is the same children. This doesn't mean if the other children is crying, this my children is crying. Okay, so and then we have return num. And remember what I told you about return. When we encounter return, the function will end. It will stop to exist. But before it ends, it has to return the value of num. Okay, we will return num, but who is waiting us to return num. In fact, n is waiting because we said here, look together, n is equal to read num. So this is what will happen. Before exiting, before stopping to exist, before these cells stop to exist, we will return the value that was here. Look, I will say control copy in here, control paste. And then all this space will stop to exist. They will disappear. I will zoom out in order to show you what will I do with the Excel sheet. I will choose those columns 1, 2, 3 and I will hide them. Right click, hide. Sorry, right click, hide. Okay, they don't exist anymore for me. They existed in the past, they did their job, they read the value 15 from the keyboard and they passed it to n. N is still alive because I'm still in this line. Now I encounter semicolon, I go to N2. N2 equal, now N2 equal double it of N. I will execute the memory state for this. Remember, I am evolving with this Excel sheet. It will not be the same the first time I opened it. I am hiding columns, I am adding columns, etc. So the memory state is in movement. Every time the program continues to execute from one line to another, the memory state changes. Even there are something that appears and disappears. So now, in this line, I have, how do I delete this break? In this line, I have a call to another function which is called double it. How do I know this is a function? Again, there is parentheses. I go, I search for the definition of the function. I find the function called double it, the same name, which takes an integer and returns an integer. So this syntax matches this definition, so I decide that this is the function that I should execute. Now this is the inverse process. Double it takes an argument, takes a parameter. So double it, first I have to reserve a memory space for double it. Let's say this is my memory space. I will call it double it. I will give it a shape of title because this is the title of the function, a box, and then inside the scope of this function, what do I have? I have two variables, not only one. Not only I am declaring num2, I am declaring also the parameter num. So I have int num and int num2. So I have two variables to be declared here. This is the first and this is the second. And as we all know now, this one I will call it num and this one num2. But when I called double it, I passed the argument n, which is a variable inside main. So I passed the value. Where this value came, it will come here. So this time, the value that is inside the n variable inside the scope of main will be copied into the parameter num, which is inside double it. So what I do is Control C, I copy this value from main and I will paste it in double it. This is the effect of the function call. This is the function call. You pass n to num. And then inside num2, I have to double the value of num. 2 times 15, which is 30. Again, here I am returning num2 and closing the curly brace. So double it will disappear, will stop to exist. Double it will die. But before dying, it returns num2. So I have to see who is weighting the value of num2. N2 equal double it n. So n2 is a variable that is weighting double it function to return to it a value. So this is the process. I take the value inside num2, I copy and I paste inside n2. Again, I repeat, even if they have the same name, if there is no return here, they will not take the same value. So I copy it, and then the return will encounter the end, and there is also, even if there is no curly braces, either this is an if statement and there is an else, every time we see a return, we return. Every time we see inside a function a return statement, this function dies. It stops to execute. Even if there are lines after the return, we don't continue reading them. This is a return statement. Return خلص اتركوا الفانكشن وروحوا على مطرح تاني. So this function, which is called double it, also will stop to exist. So I will choose the space and I will also hide. It stops to exist. Notice with me that this is fine with us. We have read a variable, we have double it, and we have the value. We still have the value. All we have to do now is to print it. So n2 equal double it n. We finished with this line. We go to the next line, which is display n2. So again, this is a function called display n2, not like the two function calls that are before. There is an equal before. Why? Because display is a function that returns nothing. It returns void. Display is a function that takes an integer and returns nothing. And this is the return type to return nothing, to return void. So display has only one local variable inside its scope. It is its parameter, which is of type int. So display int number, I will have to declare the space for the display function. Let's suppose this is it. I have to prepare the name for this function. I have to declare the name for this function. I will put it inside a box. I will also give it a nice type. And then there is only one variable called number here. I will choose this space for this variable and I will call it number. Okay, so this is display number. What was passed to the value of number? This is a parameter. This is an input for the function. Who gave this input? The function that called this function. So main called display and it sends to it the value of n2. So normally n2 is inside main and we take the value, we copy and we paste it inside the variable that is called number inside the scope of display. I take n2, Ctrl C and Ctrl V inside of display. And then what happens inside display? Inside display we are printing simply the value of number. So I take this value again and I print it on the screen, which is 30 and which is in fact what has happened. Okay, I know this is very long for you. For the first time you see a memory state, you say, what for all this process? We already know what is happening, but you have to know that I am introducing this on a very easy example so that you understand it slowly, so that later when we introduce pointers and we see what happens with pointer manipulation, you have already been introduced to memory state. So I will continue display. After the printf, we go to the next line. We see a curly brace. A curly brace for it's like just like an empty return. We return. What happens when we return? This function will stop to exist. All this function will die. So again, on my Excel sheet, because I'm not in the class, if I were in the class, I will erase the function. So on my Excel sheet, what shall I do? I will choose these columns and I will hide them. There is no display anymore. Finish. And after calling display, after this display finishes, we go back here and we go to the next line. The next line is return 0. So after return 0, also the main function will stop to exist. So I take the main function and I will hide it also. B, C, and D columns will be hidden also. So main function stop to exist, but what we still have is the value 30. Again, I repeat a very important remark. We called it the number, we called it num here, num2 here, number here, n and 2. This is when we unhide the columns in order to show you. This is n and 2, num2. Remember here there is num, here num, but they are two different variables inside the memory state. If we name all num, or we name all number, or we name sum and 2, this means nothing. Each function has, as you can see now in the scope, each function has its own variable, just like each house has its own persons inside it. It means nothing if we have two variables having the same name, unless one variable passed its value to another, either through return, either through the parameter, the call. It means nothing to have two variables with the same name. This is a very important remark. Let's go and continue with exercise 3. Inside exercise 3, we have to write a program which calls a function to read 10 numbers. Okay, the function must be called read 10 nums. Another important remark, if I give you the function name, you have to stick with it. Here I am giving you read 10 nums as the function name to read 10 integers, and calls another function avg to calculate and return the average of the integers, and the function display to display the result. Okay, so let's do this. This is becoming a little bit difficult because we have 10 integers, and you all know that when we have 10 integers, in fact we don't declare 10 variables. When we have 3 variables and up, 3 values and up, we have to declare arrays. We do all agree that with 3 we have multiple, and with multiple we declare at least arrays. So let's change this program. We want to be reading 10 nums, and of course these 10 numbers we will be reading them, and let's declare them here. Int for example t of 10, and I will call the function read 10 nums. I will give her t, and I will give her the value 10, and then I have to calculate as the average. Okay, so let me declare the average double A equal AVG of the array T, and again every time I have an array I have to pass its value. Here too many arguments to call 10 nums. Yes, of course, 10 nums must have an array, must have two arguments, the array and the size of the array, and it mustn't return anything because it will fill the array. And now here we will see what we will do. Let's erase and double it. Let's change it to average, so it will return a double, and again it will take an array and the size of this array. And here let's see what will happen. Let's erase, and the function display to display the result, so this will be the result, but this will be a double value, so percent LF long float. Okay, so let's continue correcting this code. There is so many errors here. Double A equal average of T, read num, and then display A. So basically the main function is good now. We have to continue correcting the other. Read 10 nums. You have to fill the array T. So basically you have to do a for loop. The for loop will use an integer I, so you declare it, and then for I equals 0, I less than 10, or I less than size if you want, I plus plus. Okay, what do you do? Scan F. Every time you read one value of type integer, so %d, where do you put it? You put it inside t of I. Inside t of I. Okay. And then when the for loop finishes, I will put the curly brace that you can see. When the for loop finishes, you have nothing to do. You also finish. So you return, because this is a void function. I will explain on the memory state now why this is very different from the exercise 2. And then inside the average, what do you do? Basically, you loop over the array and you calculate the average. How we calculate the average? Integer I, integer sum equals 0, and instead of reading from the keyboard, you are going to summate over the array, and after this you will declare double average, and then you will say average equal sum over size, and you will return this value, return average. Perfect. So let's use of undeclared identifier S. Yes, this is not S, this is sum. So let's see if we can run this. Let's compile and run. Let's allow, and then we will be pointed to enter 10 numbers. 1 1 1 1 1 3 3 3 3 3. Enter. So the average is obviously 2.00000. We can precise how many decimals after the point we want to display, but this is not our problem now. Our problem is to explain to you the main thing here, which is draw the memory state. What happens when you have an array? Okay, there is something different when you have an array, and you will understand it more precisely when we introduce the chapter arrays and pointers. So for this exercise 3, let us examine what is the memory state. So this is our exercise 3. This is the main that calls read 10 nums, then average, then display, and here is our memory state. First, we declare an array of 10 elements, 10 integers, and a double variable. And notice with me that the double variable size in the memory is double the integer size. Here you take two integers to make one double variable. As you can notice also, I will zoom in, this array is indexed from 0 to 9 because this is a 10 integers array. So it will be indexed from 0 to 9, and we have another variable a of type double. This is the memory space inside the function main. So first we declare them, the array t is empty, and then we read 10 nums. We invoke the function read 10 nums, and I pass t to the small t variable, and I pass the value 10 to the variable size. So first I have the function read 10 nums. I have prepared it already. I will unhide it so that you can see it. Okay, I have the variable t, the variable size, and the variable I. Why? Because inside the function I have declared also the variable I. So those three variables are called the locals of the function read 10 nums, and this function does not return anything. It returns a void. And this function, the t, takes the value of the original array t. And here we don't copy and paste what was here. In fact, there was nothing. But because this is a special variable, because this is an array, it has a special treatment. In fact, what happens here is that actually t is a pointer to the variable capital T, and we will understand this in the next chapter. For now, just keep in mind that here you have an you have an arrow that tells this variable that your original value is here. Okay, let me take this array, give it a special color, a special shape, so that you can see it. Let me color it in red so that you can see that there is that whenever I say t of 1, for example, I will fill this value. If I see small t, if I say inside the read num t of I, it means the element of the original array which is inside the main function. So what happens here also, size will receive the value 10, and I will begin by taking the value 0, and in each iteration it will be incremented by one value. So the I will be visited 0, 1, 2, 3, etc. So let's begin with 0, and then we will scan F1. So we will copy this value 1 into and t of I and t of 0, which is here. I will put 1 here. Then I will be incremented to 1, and the user will enter the second one, which will be copied here, and I will be incremented to 2. The user will enter the third one, supposingly, which will be here. I will be incremented to 3. The user will enter the fourth one, which will be inside T of 3. I will be incremented I plus plus, so it will become 4. And we will scan F into T of 4, which will give us 5 ones, as just in the example. I entered 5 ones followed by 5 threes, and the average was 2. So here we have entered 1, 1. We have entered 1, 1, 1, 1, 1, and then followed by 3, 3, 3, 3, and 3. And I will be incremented to 5, then to 6, then to 7, and so on, and the array will be filled. Of course, the stopping condition is I to be smaller than 10 strictly, but I will reach 10, and that's why we will go out from this loop, and the function reads 10 num will execute, will finish to be existing because it did the job. What is the job? The job is to read from the keyboard and to fill the array. So this is the function read num. It will stop to exist. I will hide it now. And the same thing will happen with the function average. After read nums execute, the second line is to call the function avg and to pass to it again the variable t and the value 10. So avg is the function with one variable called t of type array, the other variable is size, the third variable is I, and the fourth variable is sum, and the fifth variable is average. That's why you can see it here. I will hide display because the turn of display didn't come yet. You can see 1, 2, 3, 4, 5 variables, and again, because T is an array, you will understand in the next chapter why T is not in reality an array, but a reference to the original array which is inside main. So in fact, T will be referring to the original array which is now filled. And what is the job of AVG? Is to calculate the average of those elements. And again, as I can show you here, we loop over the array and we sum. We initialize the variable sum to 0, and every time we loop, we add inside sum the value of t of I, which is capital T of I. So I will be equal to 0, sum will be equal to 1 because it will be t of 0. Then when I will be equal to 1, sum will be equal to 1 plus 1, which is 2. I equal to 3, sum will be equal to 3. I equal to 4, and sum equal to 4. And I equal, when I is equal to 5, sum will be equal to sum plus 3, which is 7. And then when I equal to 6, sum will be equal to 10. When I equal to 7, sum will be equal to 13. When I equal to 8, sum will be equal to 16. When I equal to 9, sum will be equal to 16 plus 3, which is 19. And maybe I missed something. Did I miss something? I missed 1. Finally, sum will be equal to 20, I think, because 3 times 5 is 15 plus 5, 20. So I missed something. I missed one. So in fact, we will have 20 over 10, and the average will be, look here, average equals sum over size, 20 over 10, and the average will be equal to 2.0, and we will return this average. Oh, sorry, 2.0. Okay. We will return this average. Return average. Who is waiting to get the value of average? A. So this the A of main, look here, we are inside the function main and we call the function avg. So the variable A of the function main is waiting the function avg to return, and when it returns, the value it is returned will be put inside A. So what did the function avg return? It returned the value of average. So we will take the value of average and we copy and we paste here inside the variable A. And then again, because it returned, the function avg does not exist anymore. So I will hide it, but before I will hide it, I will unhide the function display that I have already prepared, because you know that we will be using it now. So goodbye function avg, we don't need you anymore, you died. And then we will call the function display. The function display, we will pass to it the value of A. The value of A will come and will sit inside the variable number. So concentrate, I take the value of A, copy, and I paste it inside the variable number. And then what happens? All what I have to execute is printf the value of number on the screen. So I copy this variable and I print on the screen. And then the function display executes and it dies. Goodbye function display. And later also the function main returns 0 and dies, so also goodbye function main. And we have the expected result on the screen. So this is it. Let me questions you must understand about functions in imperative programming and especially in C language. How to give functions a type. So here you can remember that we gave functions a type. This average function had a type double. Another display function had the type void. The main function here had the type int. And also the read10 nums had the type void. How to give a function a type is to decide, we can decide what is the job of this function. So what shall this function do? Shall it return something? If it shall return something, what is the type of this thing it will return? So this is how we give it a type. If a function is to do something only and not to return, we will define it as a void function. What are the arguments used for? So as you can see here in the memory state, the arguments were used to pass values from one function to another. Here, double it used the argument passed into the variable num in order to double it and return it again to the function main. This is the function, the use of the arguments. Can we call any function in C from within any other function? And the answer is, of course, yes, we can call any function from within any other function. And can we define any function in C within any other function? Look with me here into the code. Can we define any function in C No, we cannot define any function in C inside another function. This is a function definition. This is another function definition. This is a third function definition and a fourth. Each function definition is outside the other. Only the call of a function can be integrated into the body of another. So we cannot define any function in C within any other function. And the fifth question is, what is the difference of parameter and argument? We will see now parameter versus argument. A parameter refers to any declaration within the parentheses following the function name inside a function declaration or definition. This is a function definition. Okay, what is a function declaration? You take the first line of the function, you put semicolon, okay? This is a function declaration. Only the first line, the name of the function, the return type of the function, the parentheses, okay? And then instead of opening curly brace, closing curly brace, you put a semicolon. So this is a declaration. Also, you can write it like this. Let's use this one. Copy, paste. This is also a declaration. You can remove the names from a declaration. It will stay valid. This is also a declaration. What is a function definition? All of this is a function definition. What is a function call? Here is a function call, when you call the function. So this is a function call. Also, this is a function call. This is a function call. This is a function call. Printf is a function also. Scanf is a function. This is a function declaration. And this is also a function declaration. And this is a function definition. And so on. So example, when you have int max, int a, comma int b, there is a declaration and a declaration inside the parentheses. So a and b here are called what? Are called parameters. However, what is an argument? An argument refers to any expression within the parentheses also, but of a function call. Example, int m equal max of 3 comma x. 3 is an argument because this is an expression. X also is another argument. So here, for example, t is an argument. 10 also is an argument. But int size is a parameter. Int t brackets is a parameter. Okay, double number is a parameter because this is a declaration inside a function declaration or a function definition. So this is the difference. What is the difference between a function definition and a function declaration? You already seen that. Defining a function is where you actually provide a definition, what the function actually does. You say what it does, not only what it takes and what it returns. So it has curly braces. For example, int add 2, which take two parameters, a and b, and we define what it does. It returns a plus b, semicolon. A declaration, declaring a function, is simply telling the compiler about the function. For example, you declare it, you don't open curly braces, but you put a semicolon. And you can also write int add2 just like I show you, int comma int without saying a and b, because in fact you are not using them now, you only are declaring what the add2 do. Here we read add2 is a function that takes two integers and returns an integer value. So what is a function called now? Every function in C may be called from any other or itself. This is an introduction for the recursion. A recursive function is a function that calls itself. Each invocation of a function causes a new allocation of the variables declared inside it. This is a very, very important remark that at the end of this lecture I need you to focus and to understand. Each invocation, each one of the invocations of a function causes a new allocation of the variables declared inside it. If you call the function, the same function, if you call it twice, there will be two places in the memory state for this function, with two places for each of the local variables. So declarations had something missing. In fact, we are auto skipping the keyword auto. The keyword auto is automatically allocated. Here is the keyword auto. But let me recall you first. This is an example of function definition with curly braces, and this is an example of function call. The function call, you don't have the return type of the function, you don't have the declaration of the parameters, you have the arguments instead. What is the keyword auto? The keyword auto means the storage for the auto variables, automatically allocated on function entry and automatically freed on function return. What does this mean, automatically allocated and automatically freed? Because there is another way of allocating variable and deallocating it. There is explicitly allocate and explicitly freed, which we will see later in this course. So that means that, for example, let's take this example. We have int main return 0, and inside this main function, we are declaring a variable called var underscore name. In fact, we should write auto int var name, but what we do, we are writing int var name, and we are skipping the keyword auto because it is automatically, by default, it is auto. If we don't write auto, this means it is auto. What does this keyword mean? That this keyword means what I was doing in the memory state. Every time you see a declaration for a variable, you automatically allocate it. And remember, every time we finish with this space, we automatically delete it. We don't wait for the programmer to say, please delete this memory space. I will not use it anymore. I finish with it. And anytime I see a curly brace, I automatically deallocate the block. Anytime I see an opening curly brace, I automatically allocate the space needed inside this block. So I see an opening curly brace, I allocate G, A, etc. Let's finish our lecture today with this exercise 4, which is a very easy exercise, but it draws the attention on the allocation, on the memory allocation. So exercise 4, write a program which does call the function read num to read a number and return it, the function double it to calculate the double of the number, then again the function read num to read another number and return it, the function double it, and a third function display to display the sum of the results, so the sum of the doubles. And then we have to quickly draw the memory state to see if we really understand what is happening. So let's go to the code. We have to read a number. Remember, if you have to read a number, one number, you have to return it. Okay, I will change this into an int. Let me delete the lines before I wrote when I was explaining to you declaration and definition. So, and I, let me read this inside I. Int I scanf and I, and let us just return I. This is read num, and the function double it, you give me one number, I will return its double. If you give me the integer, the double of an integer is also of type integer, so I will take int I equal 2 times t, for example, to keep the old, and I will return simply I, and now display will remain the same except for it is taking an integer. I will remove the comment, and now I will see what shall I do with the function main. I have to read a number, double it, read another number, double it, and display. The question here is the following. Do I have to define twice read num and double it? The answer is of course not. You define only once, but you call twice. So, I will declare 4 variables, 2 to read and 2 to double, and then I will say n1 equal read num and 1 underscore 2 equal double it of n1. Now to read the other, and 2 equal, again I will call the function read num, and now n2 underscore 2 equal double it, but this time I will pass the argument n2, and then I will have to display the sum of these two numbers, so I will call display, and I have to display the sum. I can pass as arguments, recall, I can pass as arguments an expression, not only a variable. So I will pass the expression n1 underscore 2 plus n2 underscore 2. And now I will compile. And run. I will allow. And he is waiting for me to scan the first number, let's say 10, the second number 2, and the sum, the double of 10 is 20, the double of 2 is 4, so the sum of the double is 24, which is correct. Now, before we finish, we have to draw the memory state. Let's draw the memory state. Let's go to exercise 2, duplicate this because it has all, move to the end, and say, this is exercise 4. This is exercise 4. So first we have n1, we have n1 underscore 2, and let's copy these two variables into n2 and n2 underscore 2. So I have my locals, 4 integers inside main, 4 integers declared. And then I called the first time read num. This read num, it has integer I, so I will change the name here into the integer I. And suppose I gave him 10 and then 4. So let's say 10, 4. So I will take the value 10. It will be returned to n1 and then passed to double it. Double it will take the value, okay, double it here, it takes t and it has I. So this is t, it is 10, and then inside the variable I, it will double it. And then, as you all know, I won't hide this, I need you to see it, but I will insert a shape in the form of X. Can I have a shape in the form of X? Okay, copy paste. So that you can see that once read num is executed, it will be liberated. It will not exist anymore. And I here is copied and pasted into n1 underscore 2. And then double it will be freed also, because double it for the second time will be freed. So we finished this line, we finished this line. Again, we will call n2 equal read num, but this is another call for read num. So I will allocate another place for read num, inside which I will read the number 4, and then I will return it this time to n2. And another place for double it, because it was called again. But before I use double it, I have to free read num, because I finished with it. And then I call double it and I pass n2 and I receive the result in n2 underscore 2. So n2 will be copied into double it, then doubled inside the I variable, and then the result of the I will be copied and returned to n2 underscore 2. It will become 8. And then the second double it will be deallocated. So all this memory space will not exist anymore inside the memory. And then we will be calling display and passing to it the expression value of n1 underscore 2 plus n2 underscore 2. So we will be passing 20 plus 8. 20 plus 8. What is the value of 20 plus 8? Of course, 28. Sorry, we enter 2. We enter 2 here. So this is a 2. This is also a 2. The double of 2 is 4. So this is a 2. The double is 4. And here we have 20 plus 4, which will be displayed here 24. And this is it, the value 24. And of course, the function display will be deallocated, and finally the function main will be deallocated. So also we will put a red X over the function main. Everything in the memory will be liberated and after you have executed your program. So by this we will end our lecture today. Next time we will introduce recursive function, their types and their rules.